Here we try to find electric force acting on one of the charges, and here we pick Q3 and we try to find the net force acting on Q3 by two charges Q1, Q2. The configuration is a right triangle, and we have distances on the figure, and we have the sign of the charge also on the figure, and the magnitude of charges are given. So first we need to draw forces acting on Q3. This part is extremely important because the rest of the problem depends on how you draw your vectors, vector F1 and F2. If you make mistake in this part, the rest of the problem is wrong. So first let's look at the force acting on Q3 by Q1. So we put the point of the action of the force on Q3 because we're looking for forces acting on Q3. Then we say Q3 is negative. Look at it, is negative 2 microcoulombs. So it's negative. Q1 is plus. So 1 is plus, 1 is negative, means this is an attractive force. So it means Q1 pulling Q1 towards itself. So the arrow is toward Q1 because it's attracting Q3. If we were asked to draw force acting on Q1 that we do not need it in this problem, then we put the point of action on Q1 and the arrow facing Q3. But here we talk about force acting on Q3. Now for Q2 is negative 3 microcoulombs, and Q3 is negative 2. So here we have negative and negative. So here we have repulsive force. So Q2 wants to push away Q3 from itself. So it's repelling Q3. So we put the point of action of the force on Q3, but the arrow is moving away from Q2 because means this Q3 is pushing it, to the left. It's pushing it like, imagine that you're pushing somebody in the back to get away from you. So that's the way we draw these forces. This problem actually is easy because what happens that our forces F1, F2, they're already in X and Y direction. So first, that was drawing. Now for part B, calculate the force acting on Q3 by Q1. Label this force F1, F1. So our formula is KQ1, and because the other charge is Q3, our distance between these two charges is square. K is electric constant. Is 9 times 10 to the power of 9. Actually is 8.99 that we can round it to 9. Then Q1 is 3 microcoulomb. So for macro we have 10 to the negative 6. And then Q3 is 2 times 10 to the negative 6. Distance between these two, between Q1 and Q3, between Q1 and Q3 is 3 meters, so 3 squared. Now pay attention. Q3 is negative, but we do not put signs in our formula. Actually, this sign, we use it already in the direction of these vectors. So we do not need to put the sign of the charge in the formula. Here we calculate this. This is the answer in newtons. And then also we calculate the force acting on Q3 by Q2 and label this force F2. Again, we put the formula, we put the numbers in coulombs. We change macro to coulombs by multiplying 10 to the negative 6 to our number, and then we calculate this number. Now find the component of force F1 on X and Y axis. Let's see which one is F1. F1 is one that is along Y axis. So this F1 is actually F1Y, and it doesn't have any X component. So X component is 0 and we have only Y components. Let's look at here. F1X is 0 and Fy1 is just exactly F1, and we put that number because F1 is already in Y direction. Now find the components of force F2 on X and Y axis. Now F2, let's look at F2. Okay, F2 is also along X axis. Is in negative X direction. It doesn't have any Y component. So F2Y should be 0. And F2X is the same as F2 because it's already on X axis. So that's why here we put F2X the same as F2. We just put a negative sign to show that it's going to the left. F2Y is 0. So find the net force in X direction. We have F1X and F2X. And here F1X is 0 and F2X is negative 3.38 times 10 to the negative 3. We put that. This is our answer. For F0Y, we calculate F1Y plus F2Y and we get the answer. And here then we use Pythagorean theorem. Or I should remove this F2. This should be F. Sorry. This should be F. F equals F net in X direction and F net in Y direction squared. And then we find the answer. Now, in addition to this magnitude, the magnitude of force, this, make sure that changes F2 to F, please. Remove that square. I'm sorry, that was my mistake. To find the direction of the resultant means we need to find the angle that the force vector makes with a positive X direction. We are looking for this angle here. So we say tangent theta is always F net Y over F net X, and theta is tangent inverse, or we call it also arc tangent, F net Y over F net X. We put the numbers here. Make sure put the negative sign for like F1, F net X or F net Y, and then we find is negative 60.6 degrees. Okay, let's look at the picture. This is our F net X. This is our F net Y. And as you see, the resultant that we can use it like we draw a parallelogram, and the diagonal of that parallelogram gives us the resultant. The resultant has two components. This is the F net X, which is negative. So that's why we had negative sign here for F net X. You see that negative? Because it's negative here. But F net Y is plus, so we have plus here. The angle we get is here. We call it negative because it is not here, is on the negative X direction. So if you want to find the direction relative to positive X, then we subtract it from 180, because everything is 180. This angle between force F and positive X is 190.4 degrees. The force F, our resultant magnitude, is 6.9 times 10 to the negative 3 newtons, and is directed at 119.4 degrees from the positive X axis. Please pay attention. I may make mistake in my calculation. Make sure check the answer and make sure the answer is correct. Good luck.